Hello everybody, welcome to my channel Learn with Joy, and we are discussing on computational mathematics. This is very much interesting as well as exploring topic in this present era of computing. Now we have introduced our computational mathematics topics in my previous video, and today I will start the core part. Now let us see. Mathematical formulation we have also discussed in my previous video. I am discussing again. Actually, for solving an problem which involves optimization and our goal to find out the best possible value, which is maybe either minimum or maybe maximum depending on the problem. Now firstly we have to formulate a mathematical model. That is why the mathematical formulation is appeared first. So in general it is possible to write most optimization problems to form it mathematically. Let us say it is a minimization problem with respect to x. This is a x vector belongs to the n dimensional vector space with real value f I x, and here I equals 1 to m. If m greater than 1, then it will be multi-objective problem, and if m equals to 1, this is a single objective optimization problem and subject to certain equality constraints and some less than inequality constraints. If here we have seen earlier that if j equals 0, k equals 0, then this will be considered as a unconstrained optimization problem, where if I this is the objective function, and phi j x and psi k x are called design vectors, and also this is these are called constant, etc. And here the components xi of the vector x are called design or decision variables, and they can be real, continuous, discrete, and accordingly we will categorize our optimization problem later on, and it may be mixture of continuous and discrete. The function f I x, where I equals 1 to up to capital M, are called the objective functions, and in the case of m equals 1, it will be a single objective optimization problem. Now the objective function is sometimes called cost function, loss function, or energy function in the literature corresponding for which we are solving, that is either finance or economics and etc. And if there are no constants, that is j equals 0, k equals 0, the problem becomes unconstant optimization problem. And if j greater than equals 0 but k equals 0, it becomes equality constant, that is no psi kx will be there, so only equality constants part will be there. Conversely, if j equals 0 but k greater than equal to 0, then there will be no equals part, so only inequality part will be there, and therefore it will be called as a inequality constant optimization problem. Now we want to classify the optimization according to some point of view, etc. Classification of optimization problem and the terminologies used in the optimization can be diverse and overlapping, and sometimes it is confusing too, because there are several overlapping identities. Now a optimization problem can be categorized or can be assigned as easy or hard according to few practical phenomena or few certain situations, like non-linearity. If a problem is non-linear, then it is much harder to solve. And multimodality. If an optimization problem is a multimodal, I mean there are several peaks, or I may say there are several maxima or minima. This type of problem is called multimodal problem. And the second one is high dimensionality. If the optimization problem is higher dimension problem, then the vast feasible space will be there, so it is much harder to find out the solution. And the third one is constraints. It may be a complicated feasible region. I must say that if there will be so many constraints, one is equals, other one is less than, etc., etc. So what it will affect, what it will make harder the problem with irregular geometric or shape. Number one. Number two, multiple disconnected regions with isolated islands. That is, the feasible region itself is combination of some disconnected isolated regions. That is why the problem will be much more harder than usual problem. Now let us see the classification of optimization. With respect to objective, it is single objective optimization, just to have seen, and with respect to objective also, there will be multi-objective optimization, and accordingly the optimization will be called single objective optimization problem or multi-objective optimization problem. And if I categorize the optimization problem according to constraint, then it will be unconstrained or constraint. Now if I classify the optimization problem with respect to some landscape, then it will be unimodal and multimodal, just we have discussed. And if we consider if we classify the problem according to the function form, it may be linear programming, that is our traditional LPP problem, now non-linear programming, and some specialized, which is another part of linear and non-linear. Someone are calling that specialized is a kind of one or combination of both. That is and therefore some algorithmic approach, if we divide a specialized problem and some with respect to the next step, that is the algorithmic approach, we will later discuss on. Then it may be branch and bound, dynamic programming, greedy method, divide and conquer, as we have seen that in our traditional quick sort algorithm, etc. Now we may also classify the optimization problem as variable response, that is discrete or continuous, or mixture of discrete and continuous, and integer or mixed integer. And with respect to determinacy, we may call that the problem, the entire set of optimization problem may be categorized into two particular portion, that is deterministic, another one is stochastic optimization. We have already discussed in our previous lecture that about deterministic and stochastic, and just I want to repeat a portion, that if there is no randomness in a in the formulation the problem will be called deterministic. And we have discussed so far all problems are deterministic. However, if there is an uncertainty in the variable or function forms, then optimization involves probability distribution and expectations. Such problems are stochastic optimization, or it is also called robust optimization. Now we have classified the entire optimization problem with respect to how we can formulate the optimization problem. Now we can categorize our optimization problem according to the algorithmic approach. So what is it? Now the algorithm, that is how we can solve an optimization problem, it will be used to classify the optimization problem. What is it? The algorithmic approach may be broadly classified or divided into two parts. One is deterministic. Deterministic may be categorized into linear programming, integer programming, convex optimization programming problem, nonlinear programming, gradient based, that is our traditional Newton's approach, and gradient free, that is the Nelder approach. And it may be stochastic. Stochastic is also being categorized or classified as heuristics or meta heuristics, although in present era the heuristic and meta heuristics are called simultaneously, and the meta heuristic is a very popular, which may also be categorized into two portions, that is population based. There are some examples, that is particle swarm optimization and Firefly algorithm, and meta heuristics are also classified as trajectory based. Now if I just want to discuss with a few comments, that is a population based. Genetic algorithm and PSO Firefly algorithm are population based. How it is? That is, the genetic algorithm uses strings, and it may be divided into multiple agents or particles, and accordingly it finds the search space. That is why it is also called agent based algorithm. Genetic algorithm, particle swarm optimization, and Firefly algorithms are also called agent based system. That is, it creates multiple agents to find out the solution from the solution space. But in converse, trajectory based algorithm, that is simulated annealing in an example, uses a single agent or solution which moves through the design space or the search space in a piecewise style, and the steps or moves traces a trajectory in a search space with a non-zero probability. If the probability is non-zero, then it moves towards, and this trajectory can reach the global optimum value. In this way we can divide the optimization problem into two main broad categories with respect to algorithmic approach, that is deterministic and stochastic. Now if I want to categorize the stochastic learning in another step, that is, it may be divided into supervised, regression, artificial neural network, and the stochastic learning is also categorized as a unsupervised clustering artificial neural network. Artificial neural network may be supervised as well as it may be unsupervised. Now if we discuss from the starting point again for further classification. This is the optimization problem classification, that is constant problem may be further divided into 4 parts. There may be another types, and as it is exploring, so new process is generating. That is, it is unrestricted method, exhaustive method, Fibonacci method. This is a popular optimization problem, Lagrangian method, etc. And if we categorize the unconstant optimization, it is a very much challenging optimization problem. That is, it may be categorized as a random walk, univariate method, pattern search, steepest descent, conjugate gradient, quasi-Newton method, variable match. We will discuss later on in my next or later video lecture series. We will discuss each and every one. Now just we are broadly categorize the unconstant optimization problem. Now I want to give some example, that is some benchmark optimization problems. The traveling salesperson problems, we know it very well. Knapsack problem, graph coloring problem, job machine assignment problem, coin change problem, binary search tree construction problem. All these are optimization problems. Now as we have discussed that John von Neumann has started the principle of duality. And what is it? A minimization maximization problem is said to have a dual problem if it is converted to the maximization or minimization problem. If it is minimization, it is converted to the maximization, and if it is maximization, it will be converted to the minimization problem. The usual conversion, some mathematical forms are: if y equal to function of x, then the dual may be formulated that y equals minus fx. Or another way, if y equal to fx, then the dual problem may be constructed as y equal to 1 by fx. Now in recent era, there are several new approaches for finding out the optimum value of optimization problem. Now so we must say that some limitations of traditional optimization approach, that is, which is computationally expensive. For a discontinuous objective function, methods may fail. That is, if there are some isolated portions of such space, method may not be suitable for parallel computing. Discrete or integer variable are difficult to handle. Methods may not necessarily adaptive. Now what are the alternatives? In present scenario, the alternatives is soft computing, that is evolutionary approach, meta heuristics, and etc. Soft computing techniques have been evolved to address the above mentioned limitations of solving optimization problem with traditional approaches. Now from where the evolutionary algorithm started? The evolutionary algorithm started, it actually imitates the nature of animal behavior. Some biological behavior that is genetic, and evolution innovates the genetic algorithm. Behavior of ant colony, the ant colony optimization ASO. Human nervous system creates artificial neural network, and etc. If with respect to physical behavior, that is annealing process, that is simulated annealing optimization comes out, and swarming particle swarm problem PSO, learning fuzzy logic, etc. Now some references and acknowledgement. We really acknowledge some good books, internets, and efforts of some noble persons. And I am Supratim Chakraborty. Keep watching my video lecture series on these topics, as because the topic is very much interesting for mathematicians. I like it. That is why I am discussing with the topic of mathematical optimization problem. If it is helpful to you, then like and share. Thank you.